All right, the next discrete time signal operation that we're going to take a look at is what we call time shifting. And here is the definition right here of what we mean by a time shifted version of a signal. So just kind of imagine, if you will, we have some discrete time signal x of k, and we're going to create a new version of that signal y of k by shifting x of k in time. So that operation mathematically means that we're going to replace k with the variable k minus m, where m is the amount of time shift that we've introduced. Depending on the value of m, we're either going to take our original discrete time signal x and kind of slide it horizontally to the right or to the left. And that happens based on what the sign of m is. When m is a positive integer, so for instance, if m is 3, then what we would see up here is x of k minus 3, and that ends up being a shift to the right by 3 samples in time. Similarly, if m is a negative number, so let's say m is a negative 2, then right here in this math we would have k minus a negative 2, minus minus is plus, so it would look like x of k plus 2, and that is a shift to the left. So time shifting is just kind of sliding your signal to the left or the right as a function of what the value of m is. So let's go ahead and take a look at a couple of specific examples. So here is the x of k we are going to consider here. I'll go ahead and plot it as 0 most of the time, but it has 4 non-zero values of 1 at times 2, 3, and 4, but otherwise it's 0. And we are going to compute a time-shifted version of this signal. So we're going to compute y of k equals x of k plus 2. So if you remember what that means from the previous slide, k plus 2 means a shift to the left. So eventually when we replot this, this signal will be shifted to the left by 2 units of time. That's pretty easy to see, and the easiest way I think to see that is by picking particular values of k and just seeing what happens with this equation. So for instance, when k is 0, then I have y of 0, and then on the right side of this equation, 0 plus 2 is 2, so I have x of 2. So this means when I finally plot my signal y at time 0 will be equal to x at time 2. So it's as if this value has slid down to time 0. Similarly, at time 1, y at time 1 is going to be the signal x at time 3. So again, it's like this value comes down to 1. We've shifted to the left by 2 values. So if you kind of keep going with that reasoning, it's pretty easy to plot what y of k is, and it looks like this. It's my original signal x of k, but shifted to the left 2 units. All right, let's go ahead and take a look at another simple example. Let's go ahead and do y of k equals x of k minus 1. Again, what does that mean? This tells me we're going to take our original discrete time signal x and go to the right 1 unit. So we can easily figure out what that means. That means whatever was at time 2 now occurs at time 3. What was at time 3 now occurs at time 4. And then keep going, what was at time 5 now it occurs at time 6, etc. So we've shifted to the right 1 unit. All right, that is it for this video. If you keep watching, we'll get on to our next video, which will start looking at combined operations. What happens when we put together these operations we've been looking at in combination? So what if we both time shift and time scale? How do we analyze that? Thanks for watching.